Welcome to the Audio Guide to the Galaxy, a podcast put together by those of us at Scitech. This episode is the second half of the special two-part episode we've titled Walking Guide to the Solar System. My name is Leah, one of the presenters in the Scitech Planetarium, and for this episode, we're doing things a little differently. Part 1 took us on a walking tour of the inner part of the solar system, starting at the Sun and journeying through to the main asteroid belt just beyond Mars. In Part 2, we're going to pick up where Leon left off, continuing our walking journey of the outer part of the solar system, starting at the outskirts of the main asteroid belt and heading past the gas giants onwards to the far reaches of the Kuiper Belt. Now, the distance between these objects covers 4.2 billion kilometres, so it should be pretty obvious that we can't walk that actual distance in real life. Instead, we are going to do a scale model by walking around our suburb. Here's how it works. You're going to hear this beat. I want you to walk in time to this beat. You will hear 2 beats per second. In Part 1, we travelled 87,500 kilometres each beat. This week, we will be travelling much faster, about 20 times faster. At our new speed, last week's beat will sound like this, and see if you can keep up. Well, I certainly struggled to keep up. So, to match the distance of the outer solar system, each beat this episode will be representing travelling 1.7 million kilometres, or for every second, we will be pretending to travel 3.5 million kilometres. This means that in 10 beats, we could get to the moon and back 22 times. This is because distances in the outer solar system are much, much bigger. So much so that you could fit the distance between the Sun and Mars in between the main asteroid belt and Jupiter. However, not only do the planets in the solar system get further away, but the planets also get further apart the further out you go. So we need to go fast because, simply put, space is really big. That's why it's called space. If we were to travel any slower, it would take a long time to get anywhere. All right then, are you ready? Have you got your headphones in and your shoes on? Great, let's start walking. To set the scene, we left off at the main asteroid belt. Out here, there are bits of space rock in every direction you look. All of this space rock is actually the remnants of a potential planet that tried to form in the early stages of the solar system. Much like all of the inner planets of the solar system, these bits of rock were slowly joining together to make a 5th rocky planet. But its tail was less fortunate. Jupiter's immense gravity kept stirring things up, changing their orbits enough to set them on collision courses with each other. These collisions destroyed anything and everything, leaving it forever destined to be an asteroid belt rather than a planet. Speaking of Jupiter, it is our next destination, so let's get our beats going and continue our journey to the outer solar system. To reach Jupiter, we need to travel 444 million kilometres, which seems like a lot, but you'll be surprised how quickly we get there. Out here, all the planets are known as gas giants, and Jupiter is the largest of them all. Jupiter's equator stretches 143,000 kilometres around, making it 11 times greater than the Earth's. In fact, Jupiter is so big that it can fit every other planet inside it. And it's not only big, it also has a lot of mass, meaning if you could land on the surface of the planet, you would weigh 2.5 times more than you do here on Earth. Thanks to its size and mass, Jupiter's gravity covers great distances, influencing both asteroids and moons. In total, Jupiter has 79 moons. The largest and most famous of these are the Galilean moons, Ganymede, Callisto, Io, and Europa, first discovered by Galileo in 1610. And speaking of large sizes, Ganymede takes the title of the largest moon in the solar system. Not only is it 1.5 times bigger than our moon, it is also bigger than the planet Mercury. Being further out, Jupiter takes a little longer to complete one orbit around the Sun. One orbit takes it 12 Earth years, but this planet actually rotates much faster than the Earth, only taking 10 hours to spin around once on its axis. The rotation speed causes all the gas in the atmosphere to get swirled up, creating chaotic turbulence and leading to some of the wildest weather in the solar system. The most famous example is the Great Red Spot, a storm that has raged on Jupiter for centuries and likely to continue on for a few more. This mammoth of a planet sets the standard for gas giants, and by the sounds of that tone, we have just reached Jupiter. No time to stop though as we head on to our next destination, Saturn. Now, I know Leon mentioned that his favourite planet is the Earth, but for me, my favourite planet is none other than Saturn. The most outstanding feature of Saturn is its rings. While all the other gas giants, including Jupiter, have their own ring system, Saturn's rings are far more captivating. And rightly so, considering how big they are, stretching 270,000 kilometres across. For comparison, that is 68 times the size of Australia. Yet, despite their immense size, at their thinnest, the rings are just 10 metres thick. So the rings are huge, but also incredibly thin. And remember, the rings are not solid, but billions of pieces of ice of all different sizes. Some pieces are the size of the home that you live in, others are as small as the size of your fist. But despite these size differences, they all orbit around this planet together in perfect harmony. There are many theories as to how the rings formed, some suggesting that it is leftover debris from the solar system forming, and others suggesting it is the remnants of a moon that was once ripped apart. And even though we don't have a definitive answer just yet, observations over the years, particularly from the wonderful spacecraft Cassini, they've allowed us to learn a little more about these mysterious rings and indeed the planet itself. But the rings are not the only things orbiting around Saturn. It also has many, many moons. In fact, in 2019, scientists announced the discovery of an additional 20 moons, bringing the total to 82 moons that we know about. That's more than Jupiter. And it left many nicknaming Saturn as the Moon King. And for me, the reason why I love Saturn so much is because of its moons. They vary so much, from icy moons to moons that are sponge-like in shape, to moons that are different in colour on each side, and even one that looks like the Death Star. There is one moon, however, that deserves a special mention. And that is Titan. Titan is Saturn's largest moon, but it is the only moon in the solar system that has its own atmosphere. It isn't the type of atmosphere that we would be used to though. Rather than it being rich in oxygen, it is actually rich in methane, a molecule commonly associated with farts. On Earth, methane is a gas and quite smelly, but on Titan, where temperatures can get as low as -180 degrees Celsius, methane is a liquid and less smelly. And amazingly, thanks to this peculiar atmosphere, Titan has a weather cycle just like the Earth, meaning that it can form rain clouds in the sky. Although on Titan, it doesn't rain water. Instead, it rains liquid methane, falling onto the surface of the moon and collecting into riverbeds. There is a lot to discover around this magnificent planet. But as we've just passed Saturn, it's time to keep on moving. Our next destination lies some 1.5 billion kilometres away, the planet Uranus. Now, without fail here in the planetarium, this planet's name often gets a snicker or two. We can all admit that it is a bit of a funny name, and I'm never going to tell people how to pronounce it. But the reason for its name is actually a bit of an interesting story. Uranus was first discovered by William Herschel back in 1781 using a telescope. When trying to spot planets in the sky, the human eye is able to see as far as the planet Saturn in our solar system. Beyond Saturn, objects start to become too far away for our eyes to see them. So while we've known about the planets up to Saturn for thousands of years, it wasn't until we started using telescopes that we discovered new objects in our solar system. Objects such as the planet Uranus. When Uranus was discovered, however, it was initially given the name of George, or George's star, in honour of the ruling king of Great Britain and Ireland at the time. The name didn't quite fit though, as all the other planets had names with mythological origins, named after ancient Roman gods. And let's be honest, it would sound a little bizarre to recite the planet names: Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George. So, after some time, the alternate name of Uranus was suggested, which comes from the Greek god Uranos, the father of Saturn. So, the next time you have a little giggle at the name Uranus, give a thought to what it might have been called instead. Despite funny names, Uranus is a very strange planet thanks to the fact that it actually sits on its side. We all know the Earth is tilted over by about 23 degrees, which causes our seasons. Well, Uranus also has an axial tilt, except its tilt is 97 degrees, meaning as it orbits around the Sun, its north and south poles sometimes face directly towards or away from the Sun. And this creates some very different seasons compared to what we have on Earth. Uranus takes 84 Earth years to orbit once around the Sun. So this means that for 42 years, the North Pole of Uranus is facing directly towards the Sun, providing consistent sunlight. Meanwhile, in that time, the South Pole is facing in the opposite direction away from the Sun, so it experiences complete darkness for 42 years. Halfway through its orbit around the Sun, however, the planet's orientation causes the sunlight to shine bright on the southern hemisphere of the planet for the next 42 years, and thereby shrouding the northern hemisphere in darkness for those same 42 years. Although saying that the Sun is shining bright on Uranus is a little bit of an overstatement. With Uranus so far from the Sun, it only receives a quarter of the sunlight that we receive here on Earth. Looking back at the Sun from Uranus, it would appear 19 times smaller than our normal views here on Earth. And amazingly, Uranus actually takes the record for the coldest planet in the solar system, rather than the more distant Neptune. Minimum temperatures can reach as low as minus 224 degrees Celsius within the atmosphere. The reason why it records cooler temperatures than Neptune is because it generates less heat in its core compared to the other planets. There's a little uncertainty as to why this is the case for Uranus, but some scientists have suggested that it is related to its peculiar tilt. One possible reason for Uranus's tilt is that early on in the solar system, it received a massive collision from another object that caused it to tip on its side. It is also possible that such a collision would also cause the planet to release much of its internal heat out into space, thereby cooling it significantly. For now, though, this remains an idea. This distant planet is difficult to research from Earth, and we have only ever sent one spacecraft to fly past Uranus, Voyager 2 in 1986. So there are still many secrets waiting to be uncovered. The moon count on Uranus is surprisingly lower than the previous gas giants. Its total moon count is only 27. I say only 27, that's a lot compared to the one moon of Earth, but it doesn't quite compare to the 80 or so moons each around Jupiter and Saturn. This is due to the fact that not only is Uranus much smaller, in fact it is roughly 3 times smaller than Jupiter, but Uranus also has a much lower density, meaning it doesn't have as much mass as the other gas giants. So Uranus's gravity is nowhere near as strong, and therefore not as many moons. The interesting thing is that one of Uranus' moons is actually home to the largest cliff in the solar system. The tiny little moon goes by the name of Miranda, and it is only 500 kilometers across. Despite its small size though, it has a cliff called Verona Rupes that reaches 10 kilometers high. If you look up to the sky and see an aeroplane flying high overhead, that is how tall this cliff is. And yet, if you were standing at the top of Verona Rupes and decided to drop a rock from the edge of the cliff, it would take 10 whole minutes to fall and reach the bottom. This is because the cliffs are so very high and the gravity on Miranda is so very low. There are places out there in the solar system that are just so unlike the planet we call home. And just like that, we've reached Uranus. This leaves us with one more planet to reach in our walking tour of the solar system. I hope you've still got some energy left because this is going to be the greatest distance we will travel in our walking adventure. Onwards to Neptune. Neptune is the most distant planet in our solar system, being 30 times further away from the Sun than the Earth is. And to reach Neptune from Uranus, you would need to travel another 1.52 billion kilometers. My favourite fact about Neptune has to do with how it was discovered. You see, Neptune wasn't found by just pointing a telescope out into space and hoping to observe an interesting object. Instead, it was discovered by using deduction and maths. After Uranus was discovered, astronomers noticed that Uranus was behaving a little bizarrely in its orbit. It appeared as though something further out was pulling on its orbit, and scientists quickly realized that it might be a planet. So in 1846, a French astronomer took the observation of Uranus's orbit and used mathematics to calculate exactly where this mystery planet would be. And his predictions were absolutely correct. When a telescope was pointed in that direction, they found the 8th planet of the solar system, Neptune. Neptune's discovery occurred 184 years ago. For us humans, that is an incredibly long time. And yet for all that time, Neptune has completed only one single orbit around the Sun. It takes 165 Earth years for Neptune to achieve one lap around the Sun, well beyond a human lifetime. And so that meant it wasn't until 2011 that the planet returned back to the same point in its orbit since it was first discovered. And it won't complete a second orbit until the year 2176. If you have ever seen images of Neptune, you'll notice that it is dark blue in colour, vibrantly standing out against the blackness of deep space. It has this rich colour thanks to the molecules found in its atmosphere. Neptune is mostly made from gases such as hydrogen, helium, and methane. And it is the presence of methane that contributes most to the blue hue, as methane is really good at absorbing red light. So as the light from the Sun reaches Neptune, the methane absorbs all of the red light and only leaves the blue colours behind, which is what our eyes see. And speaking of viewing this planet, much like Uranus, only one spacecraft has ever flown past Neptune, Voyager 2. It passed the planet in 1989, and incredibly, our most detailed images of Neptune are from this flyby. From these images though, scientists noticed that there were interesting blemishes on the surface of the planet. Upon further investigation, it became evident that the atmosphere of Neptune was extremely windy. In fact, the fastest winds of the solar system can be found on Neptune, reaching speeds greater than 2,000 kilometers per hour. In comparison, the fastest winds on Earth only reach a meager 400 kilometers per hour. This tumultuous weather leads to storms very similar to the Great Red Spot of Jupiter, with the greatest storm on Neptune called the Great Dark Spot. This storm was so big that the Earth could have fit inside. However, these storms do not last as long as the 300-year-old storm currently raging on Jupiter. The Great Dark Spot on Neptune disappeared 5 years after it was first observed, and in its place, many other dark spots have appeared and disappeared over the years. Much like the other gas giants in the solar system, Neptune also has an array of rings and moons orbiting around it. There are 5 distinct rings circling Neptune and 14 moons. The most interesting moon of Neptune is its largest moon, Triton. Triton accounts for 99% of the total mass of Neptune's moons. It stretches 2,700 kilometers across in size. The next largest moon is only 210 kilometers in diameter, making it 6.5 times smaller. Due to its size, Triton was the first Neptunian moon discovered, spotted only 17 days after the planet itself was found. Despite the quick discovery, it took another 100 years before scientists found any more moons around Neptune. And yet Triton remains the most intriguing. Firstly, it is the only large moon in the solar system that orbits its planet backwards. While all the other moons orbit the planet in the same direction as Neptune's spin, Triton is orbiting in the opposite direction. This strange characteristic suggests that Triton is not a natural moon, but rather that it was captured by the planet's gravity at some point in the past. Such a process would cause havoc on all other orbiting bodies around Neptune, disrupting their orbits by either colliding with them or flinging them further out into space. This explains the eccentric orbits of the other moons around Neptune, and possibly why there are fewer moons compared to the other larger planets in the solar system. The future doesn't bode well for Triton, however, as over time its orbit is decaying and slowly getting pulled closer towards Neptune. Billions of years from now, its orbit will become incredibly unstable and it will crash into the surface of Neptune. Before it meets its demise, there are some interesting things occurring below the surface of this moon. Being so far away from the sun, temperatures can get as low as minus 235 degrees Celsius. But it's not a frozen world, as geological activity takes place on the moon. Observations have shown that it is quite a young surface, with very few impact craters, suggesting that over time the surface is able to renew itself thanks to volcanoes. These volcanoes, however, are not like the ones here on Earth. Instead of erupting lava, these volcanoes spew out ice, making them cryovolcanoes. Internal heating within the moon allows for pressure to build up below the surface. Eventually it reaches a point where the pressure gets so great that it erupts, breaking through the crust and spreading ice particles high into the sky and falling back down to the icy surface. By the sound of that tone, it means we have reached our final destination, Neptune, 4.5 billion kilometers away from the Sun. Beyond our final planet lies another asteroid belt known as the Kuiper Belt. The Kuiper Belt is home to many icy objects that are remnants of our solar system's formation, thereby telling us a lot about the solar system's past. In amongst these cold, icy rocks are a few special objects known as dwarf planets. The most famous, of course, is none other than Pluto. Pluto has had a lot of controversy over the years, and many still hold on to the fact that it is still a planet in the solar system. But unfortunately for Pluto, it didn't quite make the definition of a planet, as it has not been able to clear out a path in its orbit due to its smaller stature. And it is not alone in that category, as we now have 5 confirmed dwarf planets in our solar system, the most distant of which is Eris, which takes 558 Earth years to complete one orbit. And while it may seem sad to think that Pluto is no longer regarded as a planet, in actual fact, it is quite an exciting thing. Because it means that we have a greater understanding of our solar system than what we did 30 years ago. And as we continue to explore more of this part of space we call home, who knows what we might discover in another 30 years. That does bring us to the end of this special episode. We undertook an incredible journey, starting from the outskirts of the main asteroid belt and finishing up at the furthest planet, Neptune. If we were to continue walking, eventually we would leave the edge of our solar system and head out into interstellar space. But it would still take us walking for another 4.5 months before we reached our nearest stellar neighbour, Proxima Centauri. I don't know about you, but I don't think I could walk for that long. And yet, while that might seem like a long time, if we were travelling on a beam of light, the fastest thing in the universe, it would take us 4 and a bit years to reach Proxima Centauri. While it is physically impossible for us to actually travel 11.5 times faster than the speed of light, luckily for us, we are only limited by our imagination. So keep on walking and exploring. Who knows what you might discover. That's it for this special episode of Audio Guide to the Galaxy, but remember, you can always find the universe just outside.